Hi, in this video I'm going to quickly explain why a faulty element, heating element, this happens to be a dishwasher element, causes an earth leakage trip or your RCD to trip. That is the device that has the live and the neutral, and often when you press it, this drops down. It measures the difference between the live and the neutral. Why is that tripping when there is a faulty element? Right over here I have a dishwasher element. It's a 2.7 kilowatt element. This is fitted onto a Miller dishwasher. It has become a bit faulty. This runs at 230 volts. Just inspecting it, one can see that there is some damage here on the side. There's some swelling and some deformation. It's not supposed to have that kink, and even if I feel it, it's quite rough. Right, so what I'm going to do is I'm going to first measure the resistance between the terminals. This is the element, the nichrome wire or whatever wire is inside here that gets hot, and you can see there it's less than 19 ohms, telling me that that is fine. Now what I'm going to do is put my 1 multimeter clamp over there, and I'm going to measure the resistance between that and the casing. Now this casing is steel and it heats up and it cools down many times, and because this is in water, sometimes we get moisture inside here, we get an insulation breakdown, and we find that the resistance between there and here reduces. Now why is that a problem? Because this, as you can see, there's a plate here. This is actually mounted onto the chassis or the inner part of the dishwasher, and if this was in an oven, it would also be mounted onto the chassis of the oven, and that is earth. Chassis is earth. So that means that over here, this would be where my earth wire would be connected. So what you'll find is that there's often a clamp, or this over here is earth. There would be my earth wire, and all my earths would be connected to the earthing bus bar. So why that's a problem is if there is an insulation breakdown between that point and say the casing, then current will be escaping to earth. Right, so having a look at my meter, right, so I have my crocodile lead there, I'm measuring resistance, and I'm going to just measure the resistance around this element. So I'm going to start here quite close to where the damage is. There is a bit of damage here, and there's the multimeter, and there we can see it's just less than a mega ohm there. It's about 780 kilo ohms. A little bit of an insulation breakdown there. If you look at that value, you can see that 80 kilo ohms, it's actually less. If I squeeze this a bit and shift it around, there, look at that. 46 kilo ohms, 50 kilo ohms. So there's definitely an insulation breakdown somewhere over here. It even goes down to 30 kilo ohms. Right, and just measuring over here, I mean, you could take some sandpaper and just sand it a little bit, but look at that. Yeah, so 60 kilo ohms, this is definitely an insulation breakdown. There might be some moisture in here. So this element is now faulty. Right, so what is happening there is around the wire here, we've got that tube. That tube is connected to earth, and current is actually leaking to earth. That means the current coming in and the current coming out are actually imbalanced. Right, so straight current is going to earth, which means there's an imbalance. And just having a look at the earth leakage circuit breaker or your RCD, if there's a difference of 30 milliamps or more, this will trip. That means the live current is 30 milliamps higher than the neutral current. Right, in the case of this element, as more and more of the insulation breaks down, we get a higher earth leakage current, and when we get that earth leakage current, it will then trip the earth leakage circuit breaker. It won't trip your line circuit breaker, the circuit breaker which is feeding your dishwasher, for example, because the earth leakage current in this case was only small. That is why it tripped the RCD and not the main circuit breaker, say for your oven or your dishwasher, because it's not like the element wire over here suddenly shorted onto the casing, therefore initiating a much higher current. That would trip the circuit breaker. In this case, this is a slow insulation breakdown, and eventually it actually trips the earth leakage. Right, so this is what the cross-sectional area looks like. There's the electrode, and around here is the steel. So what I'm going to do is put my lead over there, and then I'll put my other lead over here, and we can see, look at that, 90 kilo ohms or 160, 190 kilo ohms. I should be getting no resistance here. So that means that somewhere along the path, the electrode inside, the resistive element, has become too close to the steel, or possibly has ionized the insulation and it has reduced the isolation. Therefore, it is now going to trip the earth leakage. So what I've done is I've got an element made in the same design, so I can use this element instead of this element. Right, and just to show you, here are the terminals for the resistor inside, and just to show you, they're 18.6 or 18.7 ohms. So it is matching the other element, and that works out to be close to 2.7 kilowatts for this element. And just to show you, if I put my one lead over there and my lead over here, you can see there is no leakage. No current is flowing here, completely isolated. This element is brand new, and therefore, as you can see, I'm not getting a resistance. I should not be getting a resistance, and in this case, I'm not getting resistance, which is telling me that the element is in good working order. Right, now just analyzing some of the electrical values, the element which I showed in the video is a 230 volt element, and it was marked as 2.7 kilowatts. Now I measured the resistance and it came to 18.8 ohms. That means I was measuring the resistance between the element terminals. So it should be a lowish resistance. Now if I calculate what the current would be, in this case it would be 12.23 amps. Using the power VI cos phi formula, if I work out what the calculated power would be, I get 230 volts. In your case it might be 110 volts or 220 volts, but in my case it's a 230 volt supply times the current times 1, because the power factor is close to 1, because this is basically just a resistor, and I get 2.8 kilowatts. Now if the power factor was say 0.96, yes, it would be closer to the 2.7. It's a slight inductance in there, but it's mostly resistor. But the point is that the calculated power and the stamped power, what says on the body, are very close, and that is how I know that this resistance value of 18.8 ohms is a realistic value. Now, if you're doing your resistance measurement between these same terminals and you get 5 ohms or something low like that, now just doing a calculation, if I want to work out the current, it's the voltage divided by the resistance. In this case, it's 46 amps. Now, that is very high current for a domestic dishwasher, and what would happen is it would want to pull such a high current and it would actually trip the overcurrent circuit breaker. Notice that this overcurrent circuit breaker is rated at 20, and 46 amps is very high. Now if you compare it to what it was, it should have been about 12 amps. So we can see that 46 amps is a faulty condition. If we just work out what the power would have been, this element would want to draw 10.6 kilowatts, which again is way above what was stamped on the body. So that tells you that the element is faulty. In this case, if you did get such a value of 5 ohms, it would trip both the overcurrent circuit breaker as well as your earth leakage or your RCD, because the current would exceed the overcurrent circuit breaker, but also your RCD would trip because the live and the neutral would be out of balance, because this current would be escaping from the body to earth. Now, in a second scenario, you might find that your resistance is too high. For example, maybe you measure 120 ohms. That resistance is high. And if we do a little calculation, we can see that the current draw, if my supply was still 230 volts, would only be less than 2 amps. And if I do the calculation for the power with a unity power factor, you can see that it is not even 500 watts, which means that your dishwasher would take very long for it to complete its cycle. It might not even get past the main wash cycle because it might not actually get hot enough. There's an electronic device in the dishwasher that measures the heat, and it knows that the dishwasher got hot enough. So in this case, it would not trip anything, but your water would not get hot enough. Now, another situation is if you're measuring between the one element and the other and you measure infinite resistance. Well, that means that inside the element, somewhere the wire has become broken, and obviously your element is faulty. And then just a reminder that these elements do come in different sizes, different shapes, and I hope that was helpful, and thanks for watching, and cheers.